Another draft physics video presentation. Unification theory this time. So that ought to be more interesting, right? Let's get to it. I did look under unification theories, and there's some crazy people with their theory of everything that's wooier and more, abstract and bizarre than the conventional notions. Obviously, they can't get much wackier than multiverses and entanglement and all of that kind of mush, but still pretty mushy. So nothing in the running, frankly, except for me. It kind of goes back to the basic stuff, just realizing that the inverse square law, I guess it's pointing over here. So the Science Asylum guy did a video last year sometime, or year before last, kind of pointing out that the inverse square law is everywhere, and all it really means is that, if you spread something over a surface, like a sphere, grass, I plant grass on a sphere that's this big, and I make the sphere this big, it's going to be 4 times less grass to cover all of that surface. As you double the distance, you quadruple the amount of surface you cover, and that's the basic principle, and everything does function based on that principle, and that principle is clearly just a radiant principle. It's just everything coming from a point in the outward direction from the center of something's gravity, for example. And so whatever it is you'd be shooting, bullets, BBs, whatever, would spread in that manner. And the same is true for the inverse. So if the lights were on around the room, you would end up with the same kind of effect, in the sense that because you're that distance, if I was to make the room smaller and have the same amount of lights, the lights would all end up closer to me, and that means I'd get 4 times as much light by just moving them half the distance. And so it's completely reversible. They never want to look at it reversed for some really fundamental reason, I guess. You can sort of see that in Leonard Susskind when he teaches gravitation. He teaches it basically as fluid dynamics, and he uses a term like anti-divergence. So instead of saying convergence, he says anti-divergence, because he really doesn't want to concede that the pressure could come from the outside. Which, again, it's there as an option. It's like they stuck to this idea of a pull universe, a pull mechanism. It's something inside is making everything happen, rather than something on the outside making everything happen. And they just won't waver. They won't concede that maybe they made the wrong choice, because that requires humiliation, frankly. So I just say to the other physicists out there, the other physicist as opposed to those physicists, not claiming I'm a physicist, you're sitting here with an opportunity, okay, to sit there and just be one of the dopes who was part of the stupid engine that kept the wrong idea in power, or you can, stand up and be part of the revolution that does the right thing, fixes the broken. Be a good guy, or you can be one of the stupid guys. That's all there's going to be. Good and stupid. That's all there's going to be. Because it's going to, in hindsight, it's going to look. I did it. Okay, somebody who it had no qualifications innately. All right, and the fact that you were so rigid and so blind in your focus. You clung to these very weakly evidenced notions of waves, one of the key fundamental stupid ways of looking at things. Not understanding what a wave is, which is a bunch of little bits of stuff doing little bit things, little individual discrete behaviors, and they create something that emerges as a wave. An ocean wave is a bunch of water molecules doing individual things, having an individual experience. It's not a wave, okay, in the sense that there's no wave, like there's no city You know, in the sense that the city is made of a bunch of individual organisms and individual cars and individual things following little individual rules. And there's no city. There's just the individuals. I mean, these are kind of simple logical arguments. And again, the evidence is so lame, you know, and so thin, and yet they're so certain that they're on the right road. And I'd say the signals that you're on the wrong road are all over the place. And he points it out in this video where he says, well, yeah, this is, you know, in the olden days, they were really close to unification. And that, hey, magnetism and electricity are the same. Well, maybe gravity, and, you know, and they were maybe getting somewhere. And then they sit there and decide to do this stupid warped, bent space-timey thing and forget it. The ball game of unifying is gone. You can't do it anymore, because now you've created a function that's so disconnected from the inverse square mechanism. The thing that causes it is now fundamentally broken. When you pretend there's not a real event taking place between objects, and then you start doing the real woo of bringing back spooky action at a distance and start saying now particles have ESP and they can tell what each other's doing, woo, through the mysterious entanglement force. Ooh. I mean, it's just really bad, really pathetic, and in hindsight, you're all going to be blamable. And especially you, like I said, the modern physicist, what excuse does he have not to recognize that Eddington is a bogus experiment, that they never really have proven light spent, that the mathematics doesn't work on all those lensing images of the galaxies. The math is preposterously ludicrous. None of them have any kind of rational symmetry. I mean, it's so obviously defective evidence. I mean, realistically, thousands of satellites in space, and yet not one of them could take a picture next to the sun. Not one? For one stinking hour? You know, come on. It's just garbage science. As science, it's junk. And it's obvious. Anyway, I don't want to go on a rant about how obvious it is. So let's show some of this, and then I'll contextualize it and such.
Flow of anything, but it's still a vector field, and it has spherical symmetry.
So again, they want to call it a vector field as if it was a bunch of static stuff. And when they know it's moving the speed of light, okay, so this whole vector field thing, this whole idea of taking this moving thing and say, oh, let's just look at it when it's static, and then we'll, you know, represent it in some way. When, yeah, you can do that if you understand what you did. What you did is freeze something that's, you know, moving. And that it's a real stuff. It's real stuff that goes from point A to point B. It's real stuff traveling somewhere. And that's why it takes time. It's because it takes time to move distance. Not difficult. Again, the inverse square law and the speed of the communicating force. The force carriers, they all have the same speed. They all are obeying the inverse square law when they're spherical. And they all end up spherical because the pressure is even. From the outside in, you get spherical. If the pressure comes from the outside in, you're going to get a sphere.
That means you get an inverse square law. The same goes for the electric field around a charge. It's not the flow of anything, but...
There, so in a way, they're almost conceding the point that this has nothing to do with the charge moving. If I stop that charge, it still has a field around it. All right, the same field. And all this moving thing means is I'm just moving the field around the charge. The charge is radiating light. I'm moving the light from over here to over there. That's the moving part. And when you move the light from here to over there, that means you're moving a field of light. That means you're going to hit something with this new field, right? Something's sitting in the dark, and all of a sudden the little light field is going to show up and hit it with light. And if you understand that light's a force, now it's not a very strong force, but it's a force. And you can have it in denser and more substantial forms that you don't call light. And again, the only thing that makes it distinctive is if I put another few other objects in there, I create something called pressure. And I can create balanced pressure. That is, as much light coming from one side as from the other side. And if the light's invisible and all I can detect is how much pressure it puts on me or how much it motivates me to move, I can say I'm not in any pressure because it's equal from both sides. And that the real thing where the real thing we call energy, isn't have anything to do with how much stuff is actually hitting us, how much energy, all right, we're being bombarded with. It just has to do with whether there's an imbalance in our field of energy.
But it's still a vector field with spherical symmetry. That means you get an inverse square law. But this poses a limitation. Gauss's law tells us
so there's no limitation except what he just said. It's if it's spherical. Now, if I make it some weird shape, which I can do with objects like a magnet or like a charged object, I can change its shape. And if I change its shapes, I'm going to change the rules based on distance. If I'm really close, then the spherical part doesn't mean much, because from every angle I'm still getting a lot of exposure. See, the further away you go, the whole idea is the angles of exposure. And so it's not until I get further away that all of a sudden the inverse square law kicks back in. But if I'm up close, it's like an infinite plane. I can't play the inverse square law game anymore. And it doesn't mean the inverse square law goes away in some weird way. It goes away in the way that you understand, in the sense that the force gets even stronger, because now you're stuck in an atmosphere that's going to give you more exposure. So if I get really close to a fluorescent light, I can't do inverse square law anymore, because the light's coming from all kinds of angles.
they're not really inverse square laws. They're inverse area laws. That r squared is really a 4 pi r.
Yeah, it's completely irrelevant. Okay, it doesn't mean anything, because we know the net effect is. So the net effect is you're quadrupling instead of doubling. And that's all the square is there for, to just say you have to double something now, because the force, you have to quadruple it instead of double it. That's why it's a square. And that's all. It doesn't matter what the constants are. So this is sort of just a distraction to make it more complicated than it needs to be. It's not really an inverse. Yeah, it is really an inverse square law.
Squared. These two laws should really be written with a 4 pi r squared at the bottom. We just clump the 4 pi together with the constant in front for simplicity.
Yeah, yeah, that's right. So you could just make the constant anything, is the whole argument, right? So just, yes, times 4. So you could do 4g. And just pretend, or you could just rewrite g to be 4 times what it usually is. Isn't that sort of just bogus? Or 1/4 g. Yes, because it's in the bottom, so you'd have to be 1/4 of the force. But whatever, it doesn't matter. It's just mathematical goop that distracts from the point. The point is everybody can understand the spherical argument. Okay, that it's expanding in 2 directions. When you go out from a circle, it's expanding this way and it's expanding that way. That's the r squared part. The amount of surface you have to cover is a lot much bigger, because it's getting bigger this way and this way.
Both of these laws require there be spherical symmetry. If your fluid flow isn't spherical, there's no inverse square law.
Well, there is, except you have to modify it to understand where you're no longer point particling, where you're no longer getting the radiation from one point, you're getting it from multiple points. As you get closer, there's more points that are affecting you. That's the whole argument. Further away, everything turns to a single point. Just like with the magnetic field. You get up close to it, you can see the north and south. You get further away from a magnet, it turns into purple. Okay, if you thought of it as blue and red, it goes purple as you get further away.
If instead of a charge, we had a charged rod, the symmetries are no longer spherical, which means no more inverse square.
Well, there is an inverse square. You just have to go far enough away, all right, for the shape to be irrelevant, because it can't be distinguished anymore in terms of the amount of force that's coming out. The straight line becomes a curved line by the rules of distance.
It's approximately an inverse square from a great distance.
No, there you go. It's approximately. It pretty much is.
Not in the details. So, as it turns out, while inverse square laws are a profoundly common pattern, they're not...
Yeah, so this is to some way trying to diminish it, because, it has rules where it's a point particle theory. It's the radiation coming from a center, all right? And if I have a whole bunch of centers, I have a bunch of points that are radiating from a center, then the inverse square law doesn't apply because you have multiple sources. But as soon as I'm far enough away that I can't see the multiple sources anymore, they're indetectable, they have no relevance, then we're back to the inverse square law.
Not quite as profound as we hoped.
Yeah, it's very profound. It's such a glaring fact that if one of these things is a virtual photon, then you don't need this bent space nonsense. And it's that clear. So you either understand that there's a real thing moving between objects. I mean, whether you call it perturbation or whatever you call it, there's something real happening. An event takes place that causes the effect. And here they have two completely incompatible notions of the mechanism. Gravity is perfectly explainable in terms of understanding it as one of these forces that's pushing. Okay, it works perfectly. It's called Mach gravity. They use it. They even teach it. Okay, because it so well describes the functions. It so well covers what we see. It completely creates Newton's equation. And here they're playing this game like, oh no, there's some huge big problem. No, there's no big problems.
That didn't stop physicists from trying to unify things anyway. In 1885...
Trying to? Yes, I'm just saying it was right there in front of their face. If they knew what we know, if Rutherford and Faraday and all those people know what we know about electrons and protons and seen all the other experiments, I just don't think, based on what their knowledge they had, if you didn't put them through the experience of being educated by a system that loves Einstein and all that kind of crap, if you just gave them the data, all right, they would tell you, okay, Maxwell will concede, yes, of course there's magnetic monopoles. The electron and proton are clearly the magnetic monopoles. You want to make a magnet, you take an electron and a proton and you stick them close together. There you go, you have a magnet.
Oliver Heaviside unified electricity and magnetism by pretty much inventing vector calculus. But then in 1915,
So again, this idea that this is all some sort of it's so obtuse, the reality, physical reality is somehow so complicated. It has nothing to do with just thinking about a car hitting another car, and parts, crush, the energy's going this way and energy's going this way, and they crush and they go this way and they go that way and pieces fly off. No, you need calculus to figure out that that's going to happen. No, you don't need calculus to figure out that you have to smash two cars together. The forces are going to cause stuff to move in all kinds of directions based on the tensions and whatnot. And that's all this is. They have no rational model. They have constructed nothing sensible. They've made mistakes and they never fixed them. They got plus and minus. Benjamin Franklin got plus and minus wrong. They never fixed it. Screwed up everything in the sense they have currents going one way in wires and voltages going the opposite way. All kinds of consequences to those mistakes. And they made the mistake of this stupid bent space stuff. They made the mistake of wavicles. They made the mistake of not even understanding polarization well enough and then presuming they have some evidence that there's some sort of magical entanglement. And then they create a bunch of dopey, out of really abstract math, this dopey notion that there's a bunch of antiparticles all over the place. Oh, yet they have a periodic table to tell you the mass of objects and how many electrons, protons, and neutrons are in it. And all of a sudden we're supposed to believe, well, there's also a whole bunch of anti-crap in there that somehow doesn't have any mass. It's just too frickin' idiotic.
Einstein ruined unification by replacing Newton's law of gravity with general relativity.
Right, and just he said the words. He did ruin it. He broke the whole game. No chance of making anything coherent or rational out of physics because you have two completely different theories. One that has the idea of a radiant force. Maxwell's drawings of charge is lines of radial force coming out from the center of the charge. All right, those are the lines of force. And then Faraday and Maxwell started screwing around with this other idea that there are lines of force, or what the magnet, when the compass needles move, those are the lines of force. And so they broke vocabulary, they broke concepts, but the charge is showing you exactly how the thing works. Charges reflect energy. that comes in, and they reflect the two kinds of energy, electron and proton, energy, inversely. One does this perfect reflection thing, and the other comes in, it does it does this thing. It inverts, like the car crash. Pieces go the wrong way.
It had to be done, but it's unfortunate. So
yes, it had to be done. It's unfortunate. Why did it have to be done? You have such thin evidence. Never repeated the Eddington experiment. Never proved that a photon is ever bent by gravity. And time dilation can be just explained as merely pointing out that when things have velocity, they're physically changed. Velocity is something you have to put into something. You have to push the force right into it. You have to have a big giant flame to push the force into it. There's energy in it, and that changes it, and it breaks its little clocks. The little clocks end up getting screwed up when you give them velocity. That's all you have to accept, and then you're done with all the evidence for Einstein. That's it, because there isn't any. You have no real evidence of anything called a time dimension. That you have any places in the universe that are frames where time is different. There are no frames where time is different.
was the inverse square law such a big deal? It's a big deal historically because it hinted that everything was connected.
Right. It hinted it was just ready to explode as we finally got physics right, because we figured out these forces are real things. And they were right on the edge of doing that. And then you took the huge Einstein detour to bullshit. Bohr and Einstein just ruined everything. Bohr with his stupid spinning electron crap. The idea of this, the moving atom, the electric atom rather than the magnetic atom. And Einstein with this pure wooey bullshit diagram of reality where I'm going to explain something by just saying nothing is telling something what to do. I mean, it might as well be angels.
Physicists got a taste and they just can't let it go.
No, they let it go. They've so let it go that it's, obvious. You let go the rational recognition of the fact that this is too coincidental. The forces all move the same speed and they obey this inverse square law. Gee, let's take that seriously. No, you didn't. You just let it go. You threw it out for a silly description rather than an explanation.
Maybe we'll unify everything in the near future. Maybe we won't.
Yes, that's all just kind of mush, isn't it? So you have no hope of unifying bent space. It's not an explanation of anything. It's saying there is no force. It's saying there is no energy. It's saying it overtly to you. And yet quantum mechanics is telling you there's strict rules about conservation of energy. You can't get away with just saying, oh, it just decided to move for the hell of it. No, you have to move it with a force. You have to hit it with photons. You have to hit it with radiation. You have to hit it with something.
Maybe relativistic gravity is so fundamentally unique,
No, it's so fundamentally simplistic and stupid. It's not even an explanation. It's just saying, we already know what the effect is. I'm just going to say the effect is magically bent nothing did it. It's not anything close to an explanation. Yeah, it should be back and such. Continuing.
can't be unified with anything.
Right, so you can't unify bent space. It's just because it's not really a physical thing. It's not an answer to the question. It's just saying magic. It happens by magic. It just doesn't illustrate anything. It's not a model. It's an evasion of a model. I mean, not that I like Einstein, but I mean, it was just sort of a wacky idea, and it should have just been recognized as but that really isn't saying anything, is it? No, it's not saying anything.
One thing is for sure, though. Newtonian gravity and electricity are incredibly similar. So
again, it's not electricity, it's charge. So, this whole thing of confusing these two concepts. Charge is the elemental function. That's what the little thing they call charges. They call electrons and protons charges. They're the elemental matter bits. Charge is what something elemental has. And the manifestations of charge is that you can position the charges in different positions. So if you take the electron and put it here and here, proton, electron, from that point of view over there, it sees electrons. From over here, it sees a dipole. From over here, it sees a proton. I mean, that's the nature of electricity, is just recognizing that if I move these electrons, if I push one electron into another electron, it pushes that electron, it pushes that electron, it pushes that electron. That one's not that hard to figure out. And the fact that the force of the electromagnetic spectrum is really just saying it's the electron force. You're manipulating the electron force, realistically. You're pushing electrons. You're making them move. You're either creating an environment where they're coming towards you because you're producing a proton field that's saying come hither, so to speak, or you're producing an electron field that's saying there's already an electron here, you have to move somewhere else. It's the only thing happening is repulsion as the force, and the absence of it is when you have attraction. It's a push universe. The field is always there. You take a little bit of the pressure away, things move into the low pressure. It's that simple. That's all these equations are saying.
Similar that it's convenient to use gravity as an analogy for electricity, which is exactly what we're going to do in some upcoming videos.
Right, so the point is, he's conceded the point. It's just too close, too similar. It's right there in front of us, and yet we're still going to believe this other nonsense that makes it impossible to make them the same thing. It just doesn't make any sense that they're so belligerently glued to these wrong notions of reality. Like I said, the stupid Bohr model, the electric atom versus the magnetic atom. They see what magnets do. They can levitate them now. They can do all kinds of bizarre and interesting things with this magnetism force. And yet they can't imagine that that's what's keeping the atom together, is that things are in stuck positions, and when they're sharing an electron, they're really sharing it. That would create a very strong bond. The electron is connected to a proton from one atom, and it's connected to the protons from the other atom. And it doesn't go anywhere. The two atoms share it, literally. Not with some weird, stupid orbital nonsense. I mean, these simple mistakes, and they won't concede, they won't give the argument any, they won't give it a minute of their time, or 10 minutes of their time, or half an hour of their time to consider, what if you are wrong? Is there a way of describing this that does connect all these dots? Yeah, there is.
So, do you think we'll find a theory of everything someday?
Not with your attitude. No, you won't. Yes, somebody else will, and then you'll be belligerently obnoxious and treat them like shit. Because you're too frickin' religious. You're just religious kooks. You have almost zero evidence to support your theory, and yet you're so frickin' sure this nonsense is right. Because you've made gods out of you're just like the Tesla nuts. You're just as bad. You're an Einstein nut, or a Dirac nut, or a Feynman nut. And that's it. You just don't care for recognizing you won't admit the fact that your physics has made catastrophic mistakes. Like I said, catastrophic, understandable, but catastrophic. I mean, getting plus and minus wrong was a huge mistake. Gigantic. And it should have been fixed. Alright, so anyway. So I'll finish up with maybe a little context drawings, but maybe we don't even need any or whatever. I'll just explain the little background stuff I decided to put on here. That this is how simple it really is. So the two top objects are representing the two charge elements. And yes, they think the proton is made out of quarks and all this other crapola. But you really don't have to believe any of that crap. There's just two essential charges that function in the atom, and that's all you need. Quarks don't play a role. Even in their model, they have no understanding of what a quark would be doing, particularly. So it's completely non-essential, superfluous, nutty, stupid stuff. You really don't need it. And obviously, they don't turn into quarks, and the quarks don't do anything. If they do exist, they exist so for such a short amount of period of time, they can coalesce back into a proton again. So what's the difference? So there's only two real things happening. There's these two charge things. And the thing to understand is the two charged things have a complement in the environment, and that is these two dead matter bits. They have a complement in the environment. There's a force that reflects off the electrons, the blue things, and there's a force that reflects off the red things. And if it's always these interruptions. All right, should be back. Better check. Yeah, looks like we're back. Anyway, little me. Anyway, where was I? All right, so you just have the two charges. They're the elemental material bits, the electron and the proton, and they have these inverse forces. And the inverse forces just represent that one reflects in terms of the energy does move the object forward from where the energy hits it. And if the blue force, say, hits the red force, it means it'll probably make an exchange perpendicular. That is, the force will reflect perpendicularly, and the energy will go into the object in that direction also, with a component in that direction, sideways. And that's the key functions. So that's all you need to create an inverse relationship that creates attraction. And the magnet is just the atoms. You get a bunch of atoms and you arrange them all in the same direction of their polarity, that is their electron heavy side versus their protons. The electrons are more on one side than the other side. It's a polarized atom, and you put a bunch of polarized atoms in the right alignment, they will produce a magnet, in the sense that the blue energy that hits the red side will end up coming out of the blue end, and red energy that hits the blue energy hits the red side, red energy that hits the blue side will end up coming out the red end. And so it segregates the two kinds of force, makes one end electron repulsive and one end proton repulsive, and that's all you need. It's not more complicated than that. And then if you take that energy, the electron energy, and you give it a frequency, that is, you pulse the energy at just the right rate, that is, you move the surface, you move an electron back and forth, allow it to move, push it, and then allow it to relax back to its position, because it's in an atom and it wants to be in a position. It's a magnet, it wants to be staying where it is. You move it out of that position, it moves back, and if you just keep doing that, you create in the environment a bunch of blue energy, okay, at a frequency, and that's a photon. That's the electromagnetic spectrum. Nothing complicated, not a big step, really simple. And then if you put a bunch of dipoles, that is, you mix stuff up with a bunch of little atoms, but the magnets are all pointing in different directions, you have matter like the Earth, and you have matter like the Moon. And they can still absorb energy, they can still absorb motion. You can still have the force hit them, make them move, and while they're moving, the force isn't getting where it was going. The movement is much slower than the speed of light, and so the force is essentially inhibited from getting where it's going. That'll create a shadow in sort between the two objects, and the two objects will end up moving into that lower pressure. That's simple. There's your unification. The game's done. You can explain all the classic experiments with this model, and even the non-classic ones, because if you understand that photons are little bits of energy that have a polarization, I mean, that line isn't too perfectly straight, it's a little unstraight, then all I have to do is put some obstacles in the way, and I'll knock little bits of the photon differently than I'll knock other bits. And if I create a polarizing filter where the photon gets converted into a little bit of electricity and then gets remade as a photon on the other surface, and I create surfaces of different thicknesses and call it a polarizing film, then some of the frequency will be distorted, in the sense they'll be out of phase, and you can rebuild those photons by putting them back in phase, by making the other photon go through the thicker object the next time, through the next filter, and they'll be back on phase, and then you'll be back to being able to see them as a photon. Photons are real rays of stuff. They have to be a certain amount of it, or you can't see it, and that's all proven science. So it has to be in the right phase. It has to have all the little elements have to be there. You can't be missing any of them, and it has to have a certain length, and that's it. Those are the rules. It isn't that there's it's not complicated. It's not even in any way sophisticated. It's so crude and simple, and yet they won't consider it. They'll say, drag. I've explained how drag can be overcome by complex things. Helium nuclei can overcome the drag problem, and a wrench can overcome the drag problem, and a spaceship can overcome the drag problem because they have arrangements of matter that take advantage of that force difference between the proton and the electron. And you can arrange them where the energy goes in, it gets trapped for 1 billion years. But the fact is, it always goes in a direction, and it always remembers what direction it went in, and it always has that bias, and that's what keeps it moving. I'm just saying this is all this whole thing is about, is just their rigidity, the fact that they just won't even consider a simple explanation. They want something complex, mathematically complex, and again, Einstein's equations don't add a huge amount of clarity. It's not like they take glasses where you can't see anything. I mean, Newton let you see a lot. Okay, you saw a lot about what planets are doing millions of miles away, and he could predict that. So you could see a lot with Newton, and you didn't see much more with Einstein. You have a much more complex equation, and what are you getting out of it? And I would argue that all you're getting out of it is realizations that maybe Newton could have made, in the sense that Newton could have understood that the sun is processing. It's not sitting in one location. Its mass moves equal to the mass moving. When the Earth moves towards the sun's also moving towards the Earth. I mean, later it's going to move in another direction, so it's not going to go anywhere. But it does actually move, and the movement absorbs energy, and that's what creates the gravity. But it also creates the fact that there'll be tiny little differences in the orbit of things closer to the sun than further away, because the sun is wobbling a little bit, and they can detect the wobble. That's it. And then you explain to Mercury's precession. I mean, it's all, you just don't need any of this nonsense to explain phenomenon. This complex, entangled expansion, all this whatever. Just, it's not necessary. Really, that's probably enough. Yeah. All right. So we'll leave it there. Get into more detail in the future videos, and the subject videos are there, mostly correct. Some modifications needed, which I'll get to and such. So till the next time. But I mean, it's this easy, it's this simple, unified, finished, done. And I haven't gotten any rational reasons why it can't be so. So all the naysayers can't articulate a reasonable, respectful sentence explaining, or paragraph explaining why it's just not possible, or what experiment proves it's not possible. I can only reason with you. I can't force you to be reasonable. Alright, till next time and such.